So good morning everyone. Today we will be doing some good problems from the chapter of laws of motion. At the end, I will be also doing few problems from variable mass system. So let's start. So the first question is, suppose I give you a block here on a surface. Start writing. The mass of the block is m and here there is no friction. So coefficient of friction is 0 and you apply a force F at an angle theta, and that force is given to be equal to some constant times time. In other words, this force increases linearly with time. So you have to find the time when block leaves the surface, and at that time you have to find the final velocity of the block. Initially the block was at rest. Okay, this is the position at time 0. And also try to calculate the displacement at the time when it leaves the surface. Try once, all of you. The main thing here is when the block leaves the surface, what will happen to normal force?
0.
0. So basically you have to try to find normal force and make it equal to 0. That's it. So let us take components of this force. So here F cos theta, here F sin theta, then mg will be acting downwards and normal force will be acting upwards, right? Now along y-axis, as long as it does not leave the surface, if it is not leaving the surface, then it will be moving parallel to the surface like this. So along y-axis there will be no acceleration. So net force along y-axis should be 0. That means F sin theta plus normal should be balancing mg, isn't it? That means normal will be equals to what? Mg minus F sin theta, and F is what? Kt. So as you can see, students, when time is very small, obviously n will be positive. Positive n matlab it is pressing. The block is pressing the floor. But the moment this t starts increasing, there will be a time when normal will become 0. So when normal force becomes 0, meaning the block is about to leave the surface, these two will become equal, right? So at what time it will leave the surface? First question, what is the answer? Mg by k sin theta. Now these values will be given, you can substitute and get the answer. So when it is about to leave, it is still here only, remember. So let us give this quantity some symbol T naught. So T naught is the time when it is going to leave the surface. So from here to here, they are asking what is the final velocity. Some students may do this mistake. They may try to use this equation and try to get the answer. Acceleration you can find along x-axis, right? Force you know along x-axis. So acceleration you can find along x-axis. Then you can find final velocity. Can somebody tell why we cannot use this formula? Ritik?
Force is not constant.
Yeah, because force is not constant, it is changing with time. So if force is changing, acceleration will also change. So don't use this standard formula, you have to go with calculus. So first find acceleration along x-axis. So acceleration along x-axis will be equals to force along x-axis divided by mass, which is the only force along x-axis, F cos theta. And what is F? Kt. Remember, theta is a constant, okay? Only the magnitude is changing. So this is the acceleration. Now how to find velocity from calculus? You can write this acceleration as dv by dt. Kt cos theta divided by m. Then you can cross multiply and integrate. So on the left side, you will get integral dv. On the right side, k cos theta by m will come outside, integral t dt. So initially the velocity was 0. Final velocity we have to calculate. And the time was from 0 to this time, right? Because up to this much moment, up to this point, we have to find the final velocity. So basically, we have to find final velocity here when time is t naught. So upper limit will be t naught. So this integration you can easily do, right? T square by 2, t naught square by 2. This is t naught, substitute here. Again, this will come mostly as numerical, so you will be able to solve it easily. However, one small correction, students. If you do this integration, then you will get directly velocity at this instant. Then you will not be able to calculate displacement. Because if you want displacement, again you cannot use ut plus half at square. You have to use calculus. And to use calculus, we need velocity function, not velocity's particular value. So don't put t naught here. If they ask only velocity, put t naught and solve. But they are asking displacement also, right? So better to integrate up to some instantaneous time t. Tell me how much will you get? This will be v k cos theta t square by 2 times mass. So this is your velocity as a function of time till it leaves the surface, okay? So at the moment of leaving the surface, what is t? T naught, substitute t naught here. But why this is important now is because we can now find displacement also, isn't it? So
Yes, sir.
this v, how will you write now? Dx by dt equals to v, then you will integrate v dt from 0 to t, 0 to x. So x is the displacement and v you will substitute here, k cos theta by 2m, integral t square will be what? T cube by 3. So now you can put this t naught here in place of t to find the displacement from 0 to x when the body is about to leave the surface. Okay. Next question. Suppose you have an inclined plane and here you have same inclined plane, same length, this distance s and this distance s is same, theta is same, but here there is no friction, here there is some friction. In both the cases, a block is released from rest at time 0, from rest, and when it reaches here, the time here is t1 and time here is t2. t1 by t2 is given as some ratio. Achha, by the way, this t1 by t2 should be less than 1 or more than 1. Sorry, here there is friction, okay? Here friction is not 0. This time taken t1 will be more or this time taken t2 will be more? Which one will be more? T1 or T2 will be more? T2 will be more because here there is friction, so it will take more time. So what they will do, this will be given as some number, let's say 1 by n, where n is greater than 1. Because just now you told T2 will be more than T1. So this integer is greater than 1. T2 is more than T1. You have to find coefficient of friction. Okay. Now, in both the cases, what is same? S is same. U is 0. So from here to here, for case 1, for first case, what will be S equals to? U is 0. So 0 plus half A T square, T1 square. This is the best formula to connect displacement with time taken, right? Now, what is the acceleration? First of all, did you notice that whatever is acceleration will be constant? Because gravity mg sine theta will be constant force, friction will be also constant. Kinetic friction it will be, right? Kinetic friction. So we can happily use our kinematic equations, the standard equations. What will be acceleration in this case? Well, the only force in this direction is mg sine theta. Normal will be here, mg cos theta will be here. So I don't need to worry about that. So if this is the force, what will be acceleration? G sine theta, right? Force divided by mass. So please remember, this is the acceleration in a smooth surface, smooth surface. For second case, displacement is same. Initial velocity is also same, 0. So half a t2 square. Here, what will be acceleration? First, try to find the force. Let me draw the force diagram here. So here, component of gravity will be mg sine theta. Here, it will be kinetic friction. Remember, kinetic friction, because it is sliding. They told. Then only to reach here, right? So this kinetic friction is Fk, which is equals to mu k into normal. But normal is balancing which force? Mg cos theta. So directly I can write mg cos theta. So it is very important, students, that in this second case, mg sin theta is greater than mu k mg cos theta. Then only acceleration will be this side. So what will be the net force? Mg sin theta minus mu k mg cos theta divided by m. What will you get? G sin theta minus mu g cos theta. Now, since both of them are representing the same displacement, you can equate these two. So half half will cancel, g common will cancel. So you will get sin theta t1 square will be equals to, here g common will cancel, sin theta minus mu cos theta t2 square. That means t1 by t2 will be under root sin theta minus mu cos theta divided by sin theta. Now t1 by t2 is given 1 by n. Substitute, theta will be also given. You can find mu value. Okay. Take some numbers. Take here 2. And for theta, take 45 degree or 30 degree like that. Done. Let's see another question. So here is a block. Here friction coefficient for static friction is mu s and coefficient of kinetic friction is mu k. You are applying a force which just makes the block slide. Here the most important word is just. And it continues, okay? And continues. Continues to apply same force. So what would be acceleration of the block? Simple question, but you should know this. So if they say you are applying a force in this direction and it just makes the body move, just. Now when will you make the body move? When the force is greater than Fs max, then only the body will accelerate, right? That means how much force minimum you need to apply? Fs max only. Let me give you numerical example. Suppose Fs max is, let's say, 5 Newton. Then how much force you need to apply? More than 5. But more than 5 is 5.0000 up to Mysore 1 also. So in calculation, we can still assume at 5 Newton it just slides. So just word if they write, you can assume at 5 Newton, which is Fs max, the body begins to accelerate. So basically what that means is the applied force is nothing but Fs max, which is mu s into n, and n here is balancing mg. And since they are asking acceleration and this force continues, the friction that acts here will be what friction? Kinetic. And kinetic friction is what? Mu k into n. N is balancing mg. And we know mu s is greater than mu k. In our theory classes, we have learned. So if this force is greater than this force, what is acceleration? Mu s mg minus mu k mg divided by m. M gets cancelled, so answer is mu s minus mu k times g. Okay. There is a block with mass m, friction coefficient mu, and they will say find the minimum applied force so that block just begins to slide. And in the option there will be mu s mg, and many students will tick that because that is what you normally think, right? The minimum force that you need to accelerate the body on the surface is minimum should be maximum static friction. My minimum should be equal to whatever is the maximum static friction. So people think the value that of minimum applied force is mu s n, and mu s n means mu s mg. However, they didn't mention the angle at which the force is applied, right? If you apply force this way, then you are right. Then you are right. Minimum you need to apply a force which is slightly equal to but greater than this maximum static friction. So in that case, you are right. But they didn't mention the angle. And it so happens that if you apply the force at some angle, then there is some specific angle, there is a specific angle at which the force is lesser than mu s mg. Now you may be thinking, why sir like that? Because see here, I'll give you idea. If you apply force at angle, one component of this force will be here or not, and that will decrease the normal force because normal force is pressing force. And if normal force decreases, maximum static friction also decreases. Got the idea? So therefore, you don't need as much force as you need if you apply this way. This way you may need some force, but at angle you will need actually even less force. But there is one specific angle that we have to search. Okay. So be very careful. Don't write directly mu s mg. So let's start. So angle is not mentioned. So let me say I apply here f. Rajit, what you wrote is fine, but theta value you have to somehow find in terms of mu because theta value is not given. So f is applied here. Let's say this theta is, this angle is theta. Take components. Here f cos theta. Here f sin theta. Here normal. Here mg. And here static friction. Now to move the body this side, this force should become just equals to maximum static friction. So when the body is about to move, friction here will reach maximum value, right? So this side F cos theta should be just equal to but greater than Fs max. And along y-axis, n plus F sin theta, n plus F sin theta should balance mg. And let us relate these two equations. How to relate? Equation 1 is F cos theta should be equal to Fs max, which is mu into n. N is how much from here? N is how much from here? Mg minus F sin theta. So we want to find F value. So this will be F cos theta mu mg minus mu F sin theta. Bring it this side. F common, cos theta plus mu sin theta equals to mu mg. So F should be how much? Mu mg divided by cos theta plus mu sin theta. So when you apply this much force at this angle, then the body will just begin to move. Till here is clear or not? But this is not the answer, remember, because there the question was to find minimum value of this force. So now we need to find the theta for which F is minimum. And that you can do easily with the help of differentiation. Yes or no? So for F to be minimum, this denominator should be maximum. And for this to be maximum, differentiation of this function should be 0. What is differentiation of cos theta? Minus sin theta. And differentiation of sin theta is cos theta. So that will be equal to 0. So from here, what will you get? Mu cos theta is equals to sin theta. So tan theta equals to mu. So at what angle you should apply force if they ask, so that you require minimum force? What will you do? Theta equals to tan inverse mu. And if you remember, this is your angle of repose also, and this is also angle of friction. Angle of friction is basically angle between normal and maximum static friction. Sorry, that angle is 90 degree. What I mean is angle between the resultant of normal and Fs max. This resultant force, this angle, the resultant force makes with normal. This is called angle of friction. And if you calculate tan theta, what will you get? Fs max by normal. Fs max is mu into n, n cancel. So angle of friction, tan of angle of friction will be mu. So once you know the value of theta at which your force becomes minimum, you can substitute theta here. But then don't substitute tan inverse mu here. Cos of tan inverse, who will try to find ma? So best way is tan theta is mu. That means if you draw a triangle, this is theta, opposite is mu, adjacent is 1. So this is root over mu square plus 1. So now you can substitute for cos theta and sin theta and check how much you get. Try. So F minimum will be when tan theta will be mu. Tan theta mu means what will be your cos theta? Cos theta from this triangle. 1 by root over mu square plus 1 plus mu. Sin theta will be what? Mu by root over mu square plus 1. So that will be equal to mu mg root over mu square plus 1. In the numerator, it will go 1 plus mu square. 1 plus mu square, root over 1 plus mu square will cancel. So you will get finally mu mg by root over 1 plus mu square. So this is the minimum value of applied force. Okay, if somebody will ask you to find contact force between block and the floor, contact force, which one will you calculate? Normal or friction or this R? Quickly mention in the chat box, or you can unmute and answer. Very good, Gautam. So R you have to measure, okay, because R is the resultant of normal and friction, and both normal and friction are contact force. So if they ask you to calculate R value, then be careful, you have to write root over n square plus friction square. Done? Shall I tell you one faster way to get this answer? If they want only minimum applied force, minimum, is a faster way to get this same answer once you reach till here. Let me explain. You got F equals to mu mg by cos theta plus mu sin theta, right? This is what you got. Now you want to minimize this force, so you have to maximize this quantity. Maximize. Now think carefully, AC chapter. This is like two alternating quantities. Think of that, A sin omega t, B cos omega t, like that. So if I represent this as a phasor, this will be having a peak value of mu, maximum value of this is mu, and phase is, let's say, here. Then cos theta has what phase difference? 90-degree more, because cos theta is sin theta plus 90. Yes or no? Sin theta plus 90 is cos theta. That means cos theta has phase difference 90-degree with sin theta. So if this quantity you represent by phasor here, this will be here. And what is the peak value of this quantity? 1. So what is the peak value of this whole quantity? Take resultant, root over mu square plus 1. Therefore, what is the minimum value of this force? The minimum value of this force is mu mg divided by maximum value of this. Maximum value of this means peak value of this. Peak value of this is this value. Did you see or not how nicely it came? See this question. Or let me draw this side. So there's a table. Here is a block, pulley, and a block. M1, M2. Here friction is mu. If I write only mu, you have to consider it as mu s or mu k. So you have to find, you know that if this becomes more and more, then one day this will slip, right? If you keep increasing this, at one point it will slip. More than that, it will 100% slip. Less than that, it will not slip. So you have to find value of M1 so that the two blocks or this block slips, so that M2 slips. So let's try to do this quickly. So here tension T, here friction, let's say right now they are at rest, so friction will be static. Same tension will act here also, right? Ideal string, so here M1G. So if you don't want the system to slip, then for acceleration to be 0, so that they don't slip, this one doesn't slip, T should balance Fs, and here T should balance M1G, right? Now, in order not to slip, this should be static friction, right? Now, you can substitute this T here, so Fs will be M1G. Now, Fs has to be less than or equal to Fs max all the time if you don't want the body to accelerate, that you remember. Fs is how much? M1G according to these equations. Fs max is what? Mu into normal. Normal here will balance whose? Mg. M2G. So M2G less than or equal to mu M2. So as long as your M1 is less than or equal to this number, the body will not accelerate. So this should be lesser than this number. Okay. When it is about to sleep, critical point, this is called your critical point. That time you can write M1 is equals to mu M2. And therefore mu will be equals to M1 by M2. Now try to remember this result. Okay, so this is when the system is about to accelerate. So if your M1 is more than this number, it will accelerate. If M1 is less than this number, it will not accelerate. When it is equal, you can say just accelerate. Just means again it is not accelerating also, accelerating also. Okay, matlab if this is 5 kg, then 5.000001 it will accelerate. 4.9999999 up to Mysore, it will not accelerate, which are both approximately 5. So how I want you to remember this problem is, whenever you see something, some mass on the table and some mass hanging, this result is very useful for the critical point when the bodies are about to accelerate. So that time mu will be equal to mass hanging divided by mass on the table. So this ratio try to remember. Okay. So let's say here we have 8 kg. Here we have mu, here is let's say 0.5. This is mass on the table, remember. Mass on the table was M2, right? Mass on the table was M2 and this is the mass hanging. What will be mu M2 in this calculation? Mu M2 0.5 into 8, 4. So if this is less than 4, it will not accelerate. More than 4, it will accelerate. Let's say this is 10 kg. So right now the system will accelerate, yes or no? Because this number M1 is greater than mu M2. This is the condition for just rest. Till this point, the system you can assume is at rest. The moment M1 becomes greater than this number, it will accelerate. So they will ask how much mass you should keep here so that the system remains at rest. How much mass you should keep here so that the system remains at rest. So for system to be at rest, what is the condition? This is the condition. Mass hanging should be less than equals to mass on the table, mu into mass on the table. Remember, this is hanging mass, this is on table mass. Or you can use this formula also. So mass hanging is 10, mu is 0.5 is half, M2 mass on the table is how much? So M2 total, let me write, okay, total. So what is the net mass which is hanging here? 8 plus M. So if you cross multiply, 20 should be less than equals to 8 plus M. So M should be greater or equals to 12. So at critical point, what should be the mass of this? 12 kg. But to keep the system at rest, what should be the mass of this? Actually more than 12 kg. But minimum you need 12 kg. Clear everyone? Keep writing. Next question. Similar only. Fast let us do. So here is a chain like this. Total length of the chain is L. This much length which is hanging is small l. So you have to find small l so that the chain does not slip. So if you keep increasing this L, I hope you know that even if there is friction here, still it can slip if you keep increasing this length here, because the mg pulling down will become more and more. So the static friction here will not be able to keep the system at rest. For not to slip, for no slipping, what was the condition, guys? Whenever you see mass on the table, mass which is hanging, what was the condition for no slipping? Mass hanging should be less or equals to mu into mass on table. Am I right? Once you check. Correct. Okay. Now what is mass hanging? Total length is L. Let us assume total mass is M. So mass hanging will be what? Total mass by total length into length hanging. And mass on table will be what? Total mass by total length into the length which is on the table. It is L minus L. M by L cancel. So from here, mu should be greater or equals to L by L minus L. So this is the condition. Okay. If they want you to find L, then you have to cross multiply. Mu L minus mu small l should be greater than equal to small l. This should go this side. Mu L should be greater equal to mu plus 1 L. So L should be less than equals to mu L by mu plus 1. If small l should be less than this number represents what? Maxima. So the maximum length that can hang without the system falling or slipping is mu L by mu plus 1. And if they ask you fraction, then you have to divide by original length. Okay. So let's take some example. Let's say mu is 1. So 1 by 1 plus 1, 1 by 2, 0.5, which is 50%. Meaning maximum 50% can hang. Maximum. Slightly more, it will slip. Less than that, no problem, right? So if L is less than this number, no problem. But it should not be greater than this number. So this is the maximum value of the length which can hang without slipping. See this question now. Suppose there are two blocks tied to a string like this. Let's say this is 10 kg and this is 20 kg. Here friction value is, let's say, 0.5. Here it is 0.2. You are applying, let's say, a force of 50 Newton. Okay. So you have to find acceleration of the blocks, friction value at A and at B. Small f, if I write, please understand, is friction, okay, and tension. Now, students, in such problem, the first thing you have to do is check what is the maximum static friction which is available. Fs max is not friction which acts. Fs max is maximum friction which is available. Of course, it can also act, but it acts when the body is about to move. So in such problem, first you calculate here friction max. So what is friction maximum possible on B? Mu into n, mu into n. N will balance. Achha, let me write 2g and 1g. Because 20, wait. Yeah, it will be too big otherwise. So mu into n at B. So 0.2 into normal here will balance mg, so 20. How much is this? 4 Newton. What about maximum friction here? Then 20 was good actually, students. Simply I made it 2. It's okay, sorry. Or do one thing. Please remove this 0. Okay, don't mind. Tell me maximum friction here. Mu into normal here will balance mg. Mg here is 1 into g, which is 10. So this is 5. So now my question is, here maximum friction 5 Newton can act this way because system is trying to go there, no, because of this force. So maximum that can act here is 5. Here maximum that can act is 4. So total how much can act in the backward direction? So since your applied force is less than Fa max plus Fb max, therefore system will not accelerate. System will not accelerate because your applied force is less than the total backward maximum friction. So system will not accelerate. So A will be 0. Clear this part? So first answer is 0. So first part to be understood. Now what are the friction? Don't say these two are friction. These two are maximum friction. Now we need to check. You have applied 5 Newton. Here friction can go up to how much? Up to how much friction can go here? Up to 4 Newton. But this is at rest. So since this is at rest and you are applying 5 Newton and here friction can go up to 4 Newton, here how much you need tension? How much you need tension here to keep this at rest? 1 Newton.
1 Newton.
So friction on B will be 4 Newton, which is the maximum friction also. Tension will be 1 Newton. Now, if tension here is 1 Newton, here also tension has to be 1 Newton. That we cannot change. In the same string, same tension. And since this has to be at rest, how much friction you need here? 1 Newton is pulling this side, so this friction should be also 1 Newton. All of you understood? Suppose if I increase this coefficient of friction from 0.2 to let's say 0.3, 0.3, then this will come how much? 6. You are applying 5, so friction can easily go up to 5. Then what should be tension? Friction alone is able to keep this at rest. Then how much tension you require? No tension.
No tension.
And if tension is not required here, here also tension is not required. So here also friction is not required. So friction here will be 0. Okay. So like that, please try to analyze and solve. And if it accelerates, it is very easy. If it accelerates, then you can write Newton's law for this, Newton's law for this, and then solve the two simultaneous equations. Because once it accelerates, you know the friction acting in both of them will be what? Kinetic. And kinetic friction has fixed formula, mu into n. This kind of questions also you should know, okay? So there are two blocks. Now you will say only one block is you have drawn, sir. No, actually there are two blocks like this. Both have mass m. Let us call this block A, block B. Here you are applying force F, 2F. Here you are applying force F. Smooth surface. So you are supposed to find normal force on A by floor and normal force on B by floor and normal force on A by B. Sometimes we call this contact force, but it is normal force if it is smooth. Okay, then how will you do this problem? Simple, students. First you take A as system. Then draw the forces. The first thing is to check whether it will accelerate or not. Obviously it will accelerate because first of all there is no friction here and this force is greater than this force. So first thing is to find acceleration of the whole system. So take everything as system. A plus B you take as system. And then tell me the total force. 2F here, F here. So total force will be F this side. Right? 2F minus F. Total mass is what? 2m. So it is F by 2m. So first find the acceleration. Now let us go with block A. Here normal force is NA, let's say. NA, let's say. NA from the floor. Then mg. Then here 2F. Now remember when the system is accelerating this way, A is pushing B this side. But the surface is this way and normal force is always perpendicular to the surface in contact. Okay, so be very careful when you show normal force here. On B by A, reaction will act on A by B. So A is pushing B this side, so B will push A this side. It is a pushing force, so it cannot be away, it has to be towards. Normal force is always towards the system. Tension force is away from system because one is pulling force, one is pushing force. So A is pushing B this way, B will push A this way. So let us call this R because N I am using here. So reaction will act, sorry, one component will act here, one component will act here. This is 30 degree. So this is also 30 degree. So this will be R by 2. This will be R root 3 by 2. I hope you understood. This is 30 degree. This is R cos 30. So R root 3 by 2. This is R sin 30. So R by 2. Now along x-axis write Newton's law. Remember everything is accelerating this side. So what is the total force this side? 2F minus R root 3 by 2. This force minus this force is equals to mass of MA, which is given as M, into A. And A we have already found F by 2M. So this will give me, this you can take here, this you can bring here. So 2F minus F by 2 will be R root 3 by 2. If you multiply with 2, it will be, or let me take LCM. 2, 4F minus F, 3F is equals to R root 3 by 2. 2 cancels, so 3F is equals to R root 3. You need one more equation to solve. First of all, did I do correctly or not? 2F minus R root 3 by 2 is equals to M into A of the block is same as A of the system. Together they are moving. And A I already found by taking A plus B as system. Advantage of choosing A plus B as system is what? You don't have to show the internal force. Same thing now you have to do for y-axis. So for along y-axis, remember there is no acceleration. So NA upward force should balance mg plus r by 2. Now don't think, yes sir, we got two equations, so we can solve now. No, NA is also unknown. Now you have to do the same thing for block B. So for block B, what are the forces? Here F, A is pushing B this way. Now this R and this R will be obviously same. Action reaction, right? So here one component, here one component. This is 30. If this is 30, perpendicular to this is this, perpendicular to this is this, so this is also 30. So this is r root 3 by 2. This is r sine 30 r by 2. Here normal force will be NB, and mg also I have to show down. Now what is the along x-axis, what is the total force on block B? R by 2 minus F, right? That should be equals to M into A. What was A, students? Can you check? I can do from here only. F by 2. Oh, sorry. F by 2M. M gets cancelled. So R by 2 equals, this F will go there. 3F by 2. 2 cancel. So R is equals to 3F. How come it is coming differently in the two? Here R is coming root 3F. Check any mistake. This is 30. Oh, students. This is 30 or this is 30? Check. If this is 30, this is perpendicular to this, no? And this is perpendicular to this. So upper one is 30 or lower one is 30?
Lower one.
This one is 30. Krutik?
Yes, sir. Lower one.
Hmm. Those things you have to be very careful, guys. See, though it is ancient Greek rule, even modern people are doing mistake. So this is perpendicular to this. This is perpendicular to this. So this should be 30. So this should be r root 3 by 2. This should be r by 2. Then along x-axis, it is 2f minus r by 2. 2f minus, this will come this side, r by 2. R by 2. 2 cancels. R is equals to 3f. So at least r we found, and it is same in both the cases, right? Okay. So once we found r, so therefore normal force will be equal to, for A, mg plus 3f by 2. Here you can stop because f and m is given to you, right? So you can stop here. Similarly for block B, you can find the normal force. So for block B,
Sir,
what was the diagram? This r was here and this component was up. So NB plus r root 3 by 2 should balance down, which is mg. So NB will be mg minus r root 3 by 2. R is 3f, so mg minus 3 root 3f by 2. Okay. If
sir,
this,
for block A and y-axis,
yeah,
it
yeah,
should be r root 3 by
r root 3 by 2, correct, because we have to change that. Thanks, ma. Who is it?
Kavya.
Kavya. Thanks, Kavya. Oh, same normal force came, no? Oh, no, not same. Here plus, here minus. So for B, I hope you can do yourself. I have done the equations. Diagram you draw properly. The question says a suitcase is gently dropped on a conveyor belt. So conveyor belt. Okay, so this is a conveyor belt. In airports and all, you will see this. So it is moving with a constant speed, 3 meter per second. Okay, so this is the speed of the belt. speed of belt, conveyor belt. Now a suitcase is gently dropped here, let's say at this point, point A of the belt at time 0. So since it is gently dropped, U of the suitcase is obviously 0. If the coefficient of friction between the suitcase and the belt is 0.5, how far will the suitcase move on the belt before coming to rest? Now the question is not properly told. They should say rest on the belt. Rest on the belt. Okay, so basically what they should tell properly is find distance traveled on the belt before sleeping stops. So till sleeping continues, how much distance it has moved you have to find. Once sleeping stops, then of course once the sleeping stops, it will not move on the belt. So how far the suitcase will move on the belt, they are asking. See what will happen. At time 0, when you put the suitcase here, the suitcase has no tendency to go this side. It has no velocity at all. But belt is trying to go this side. So this is suitcase, this is belt. A small gap I am showing for clarity. So who is trying to move? Belt is trying to move this side. So friction on the belt will be this side. Of course, kinetic friction because there is slipping. Therefore, that reaction of that friction will act on the suitcase this side. So this part is clear or not clear, that you tell me first. That friction on the suitcase will be this way. And that's why it will try to now accelerate forward because of the friction. That's why when you put on moving belt, if you put something, that something also moves with the belt if friction is strong. But if you put oil and all, then it will stay there only and only belt will move. So now once you know, and since it is kinetic friction, you know it has a fixed value, mu into n will be equal to mg. And there is only one force this side. By the way, even if you do the problem from here, still you don't have to include any pseudo force. Why, sir? Because this belt is moving with constant velocity. So it is a inertial frame of reference. When do you consider pseudo force? When the frame is accelerating. But let me do the problem from ground frame only. So remember at T0 the block was here, then it experiences force friction this side. So acceleration of the suitcase will be equal to force divided by mass, which is 0.5 into 10, which is 5 meter per second square. Okay. Now because of that acceleration, its velocity will increase. Remember, starting velocity of suitcase was 0. So it will start increasing. But initially, who is still moving faster? Belt is still moving faster. This is starting, suitcase is starting from 0 velocity. Belt is already moving with 3 meter per second. So initially, they will be slipping. But there is friction on the suitcase, forward friction, right? So now the speed of suitcase will increase with time because there is acceleration. Till when it will increase? Till both of them will have what speed? Same speed. Once both of them will have same speed, friction, kinetic friction will vanish because there is no more slipping. Got the idea or not?
Yes, sir.
So we need to now check after what time slipping will stop. So slipping stops when final velocity of suitcase becomes equals to velocity of belt. Remember, belt is moving with constant speed. Karadak, 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 like that. Now, what is formula for final velocity of suitcase? Initial velocity plus acceleration into time. Velocity of belt is 3. Initially, no velocity suitcase has. So, after what time? 3 by A, which is 3 by 5. So, after 0.6 seconds, no? So, after 0.56 are 30, right? So, after 0.6 seconds, slipping will stop. In that time, how much distance suitcase moved? Let us try to find. So, in this time, what is distance covered by suitcase? U is 0, half A into T square. So 1 5 will cancel. It is 9 by 10.9 meters. That is the distance covered by suitcase, remember. During this time, what is the distance covered by that point of the belt which was below the suitcase? In this much time, what is distance covered by belt? Belt is moving uniformly. So velocity of belt into time. No acceleration. What is velocity of belt? 3 into 0.6, 1.8 meters. So at time 0, the suitcase was kept just above this point of the belt, let's say. Then by the time the slipping stopped, suitcase traveled 0.9 meters and belt traveled 1.8. So every point of the belt will travel 1.8. So this point of the belt will be here. So how much slipping happened? This much is the slipping which happened. So it's like saying the lower part, see, block is here. If lower part goes like this, see this diagram, not diagram, this animation. So this is the suitcase. Let's say suitcase did not move forward at all from ground frame. Suitcase was here only. If lower part goes from here to here, what does it mean? This much part, the suitcase moved on the belt. Yes or no? So this is the part which the suitcase moved on the belt, but from our frame, it is this is the right diagram. You can do the same problem from belt's frame also. So what is the answer? 1.8 minus 0.9, 0.9. Any doubt is there means you can ask. Try to do the problem from ground frame once. Oh, sorry, this one I did from ground frame. Try to do from belt frame, you will get some understanding. Shall I try to do from belt frame also once?
Yes, sir.
Okay. So this is your belt. So let's say just above this point, I put the suitcase. Initial velocity of suitcase from ground frame was 0. Belt is moving with velocity 3 meter per second from ground frame. Now, if you sit here and do the problem, then belt will be at rest for you. Belt will be at rest for you. So now let us check what are the forces on the suitcase. Because there is a friction this side, which I already explained. Don't write pseudo force because belt is moving uniformly, so there is no acceleration, so no pseudo force. So friction will be here, but initial velocity of suitcase will be here now because we are doing the problem from belt frame. So initial velocity of suitcase with respect to belt will be what? US minus UB. What is US from ground? 0. What is initial velocity of belt? Belt is moving with constant velocity. So minus T. What does minus mean? It will be this side. This part is clear. Because of this friction, what will be acceleration of suitcase with respect to belt? Friction by mass. Friction was mu mg. Mu was 0.5, g was 10, so 5. And belt doesn't have any acceleration, so if you want you can remove this, or if you want you can keep it, no problem, because belt doesn't have acceleration, no acceleration. So now from his frame, how much displacement the block will have? So S of the suitcase with respect to belt, U of suitcase with respect to belt T, plus half A of suitcase with respect to belt T square. U is minus 3 into time. Now time taken is same for everyone, I told. So time taken, how much we got, students? Time taken, you check now, please.
3/5.
T by 5. Hey, 3 by 5. So 3 by 5 matlab 3 by 5 matlab 3 by 5 sir, what? 0.6 plus half. What is acceleration of suitcase with respect to belt? 5. Time will be same for everyone in this world if your watch is working. So this will be what now, students? 0.3. Acceleration was 5, huh? How much this will come? Minus 3 into 0.6 minus 1.8 plus this is 0.6 into 0.3, 0.18 into 5, 0.9. Super duper. Minus 0.9. Minus means what? You understood? From his frame, he will see it this side. From his frame, he will see block going this side. How many meters? 0.9 meters. That is the answer. Same answer previously also we got. No, because previously it was like this. Like this. So if you see it here, you will think this suitcase went this way. Yes or no, everyone? Next question, you see. The following figure shows an accelerating conveyor belt. Accelerating conveyor belt at 37 degree above horizontal. The coefficient of friction between the belt and the block, there is a block here. Coefficient of friction is 0.1. They are asking the least minimum time in which the block can reach the top. Block can reach top. Here initial velocity is 0, starting velocity. Okay, so here time taken is t, minimum time of this we want. Okay, so here the moment the block is kept, we have to assume they should have told no sleeping, okay, anywhere. So no sleeping means what? The moment you keep the suitcase or the block, it will accelerate together with the belt. So no sleeping means immediately the block's acceleration will be same as belt's acceleration. So this you remember. Let us call this A. Now to reach here, let us draw the free body diagram now. Where will be friction on the block? Belt is going this way. Sorry. Belt is going this way. Where will be friction on the block?
Forward direction.
Forward direct. That is very important, students. If you miss this, then gone case. Friction is in the forward direction. And since there is no slipping, it is obviously static friction. Why forward? I hope all of you understood. Belt is going like this, so friction on the belt will be here. Reaction of that friction on the block will be here. Obviously, it has to be here. Otherwise, how it will go forward? Which force will be here besides that? Mg sine theta. And normal, you know, will balance mg cos theta. And since you want this block to have same acceleration as the belt, Newton's law, if you write, you will get Fs is equals Fs minus mg sine 37. Sine 37 opposite is 3 by 3, no? By 5 is equals to ma. So a equals to Fs by m minus 3 by 5 g. Now this distance covered S can be written ut, which is 0, plus half a t square. S is fixed in this problem. It's given, I mean. So distance is given in this problem. It is given. So now if you want time, what is time from here? Under root 2s by a. So now you only think, students, if you want minimum time, your a has to be what? Maximum. And from this equation, a will be maximum when static friction is also maximum. So a maximum will be Fs maximum divided by m minus 3g by 5. This is what? Mu into n. N don't write mg. N was what? Mg cos theta. This is n, okay? This is n. Minus 3g by 5. M gets cancelled. Mu value was how much? 1. And cos 37 was 4 by 5. So that will be g by 5. That will be simply 5 meter per second square. Right? So this will be equal to under root 2 into, what was the distance for the belt?
Sir, G by 5 is 2.
Oh, sorry. This is 2. Distance was 4, no? The belt's distance.
4, sir.
Yeah, so 4. A is 2. So answer is 2 seconds. Mass of this chain, this is a chain, okay? So mass of this chain is 10 kg. It is hanging vertically, so G is down. You have to find mass of the segment AP. Mass of this segment AP. So let me just give you quickly how to do this. Nothing, students, just take system, draw forces, take components, and here it is equilibrium. It is hanging, so just balance the forces. So first you take whole thing as system. So tension at B will be here, like let's say TB, this is TA. Remember, wire has mass, so don't say tension everywhere same. This is 60, this time be careful, students. This is TA. So here components, this is TA will be here. So this is 60, means this is 60, right? So don't do mistake, huh? With horizontal, tension is 60 degree. This is 60. So this will be TA sine 60. This will be TA cos 60. Similarly, TB, you take components. With horizontal tension, this rope is making 30 degree. So with horizontal 30 degree, so TB cos 30, TB sin 30 and mg, right? So balance the forces along y-axis. mg will balance TA root 3 by 2 plus TB by 2. Okay, so if you multiply with 2, 2 mg will be TA root 3 plus TB. Along x-axis, TA by 2 will balance TB root 3 by 2. So I can just write TB root 3. That means TB root 3, if I substitute in place of A, what will I get? 2 mg is equals to TB root 3 means it will be TB 3 plus TB 4 TB. So tension at B will be what? mg by 2. They are asking mass of which part? AP. So we have to now consider AP as system. So AP, if I take a system, this is A, this is P, this is 30 degree, this is 60 degree. This is 60 degree, right? Again, same thing you have to do. Here already we did this part we have done same as this. Here tension will be, remember, along the string away from the body. Okay, so this is TP. Again you can do same thing, TP. This is 30 means this is 30. This is TP cos 30. This is TP sine 30 means half, and here mass weight will be mg. So vertically this component is TA root 3 by 2, same like before. TA root 3 by 2 upward force should balance mg plus this TP by 2. This is for y-axis. Then for x-axis, this one is which component? TA by 2 should balance TP root 3 by 2. So here TA will be TP root 3. So put this TA back here. What will you get? TP 3 by 2 equals to mg plus TP by 2. Then multiply with 2. Then bring this one this side. So you will get 2 TP is equals to how much? 2 mg. So TP will be mg. Now, did you notice that TP and TB are same? Because from x equation of this and x equation of this you check. See, that means what? TB is same as TP is same as TB. So from this equation and this equation, what did you notice? That TP is mg we found now. Before we found TB is what? Capital mg by 2. So mass of this AP is half. How much? Half of this. What was the mass of the whole rope? 10 kg. So answer is 5 kg. Okay. So students, variable mass systems. So without going too much into details and all, without doing too much derivations, what is the main concept here? Try to understand. Suppose you have a system, and then if you throw some mass or some mass comes in to this system, either you throw some mass from your system to outside, or from outside some mass comes. Okay, in that case you will feel, you matlab the system will feel, besides other external forces, it will feel a thrust force. And that thrust force, FTH, is given by the formula VR dm by dt. Put modulus, okay? Sign we will learn from different method. First, always calculate the magnitude. If mass is increasing, mass is decreasing, that headache you don't take. Just check what is dm by dt. What do you mean by dm by dt? Rate of gain of mass or rate of loss of mass. Like in rocket, what it will be? Rate of loss of mass for rocket, because gases will come out. This VR is what? This VR is relative velocity of dm, matlab the mass which comes out or mass which goes, which comes in or goes out. So relative velocity of dm with respect to system. This is the system, okay? So you have to include this force. So after you include this force, then you write normal. Net external force equals to ma. But include this force also. Whenever you see a system is losing mass or gaining mass, you have to include this force also, besides other normal forces whichever we have learned. So A is of the system, okay, this system. Direction of thrust force, how to find? Very simple. Just try to remember rocket. So in rocket you lose masses, right? So if mass is lost, then in rocket where does the force act? Gas in from the rocket frame. If this is the rocket, from the frame of rocket you will see gases going down, and you know force on the rocket is up, thrust force. So if mass is lost, thrust force is opposite to relative velocity. Direction, okay, direction. And relative velocity, first you have to find direction. That is easy. Relative velocity you know how to find. And in those cases, if mass is gained, then thrust force should be same direction as VR. They will say there is a rocket which starts from Earth, let's say, and it is ejecting gases at some rate which is unknown. It is going up with acceleration 100 meters per second square. Its mass is, let's say, some kg like this, and the gases are ejected with relative velocity. Directly they will tell, let's say 50 meter per second. So what you will do? Normally what forces you will draw on the rocket? mg normal. But normal here you have to write 0 because you are accelerating upward. So when you calculate acceleration, you are assuming it is going to leave the surface. So since you are leaving the surface, normal should be always shown 0. But then who is taking it up? Obviously the thrust force. So these are the forces. mg from gravity, and there is no normal, and as gases come out, it is losing mass. So relative velocity is down. So thrust force will be up. So now write net force. Thrust force minus mg equals to ma. Thrust force is VR dm by dt. That will be ma plus mg. So from this equation, you can calculate dm by dt. Okay, try yourself. There is a cart here with sand. Sand and cart, it is moving with velocity v. Surface like this. Smooth surface, okay, no friction. And a small hole is made here. And the sand starts leaking out. So they will ask one very interesting question. As the sand comes out, what will happen to the speed of the cart? So as sand comes out or leaks out, V increases, decreases, remains constant. There is no external force on x-axis, remember, but there may be thrust force because it is losing mass. When you lose mass or you gain mass, there might be a thrust force. Let us check what is the thrust force here. VR dm by dt. Now obviously dm by dt is there, mass is leaking. So dm by dt is there, some mass is lost in some time. But students, is there VR? Check. This is your system, the cart is your system. So cart is going with speed v. When the sand is coming out, at that moment when it is coming out, whatever velocity it may have, it is only along y direction. So along x direction, the velocity of this sand will be same as cart only, because that sand was moving with the cart. Agree or not? So because the sand has same velocity as the cart, relative velocity will be what? Velocity of dm minus velocity of system. So this is v minus v0. So thrust force is 0. So now no thrust force, no other forces are there. Therefore, velocity remains constant. There is a cart which is moving, and from here sand or some water is dropped gently. Sand is dropped. So now as more and more mass comes, what happens to speed, they will ask. So as sand or water comes inside, what happens to speed? Now think carefully. Along x-axis, okay? If you sit here, ask what is the relative velocity of dm with respect to the cart. Cart is your system. Now along x-axis, dm is coming this way. So there is no velocity along x-axis for dm. And cart's velocity is this side. So therefore, relative velocity of dm is where? This side. So if you sit here, you will see this will have relative velocity this side. Minus sign means relative velocity of these sand particles which are entering the system will be this side. Now, since you are gaining mass, mass is gained or lost here? Mass is gained. When you gain mass, what I told? Thrust is where? Thrust force is opposite to, sorry, check once. In rocket, you lose mass, so thrust force is opposite to relative velocity. Here you are gaining mass, so thrust force will be in the same direction as relative velocity. Relative velocity is minus, matlab this side, so thrust force will be also this side. So now if thrust force is this side, what will happen? As sand comes inside, V will decrease. Similar question but different answers. Okay, right, fast. So here what is happening is, on a weighing scale, we are going to drop a chain. Okay, chain whose length is L, mass is M, and linear mass density is lambda, which is uniform. So I can write M by L. You have to, this is at time 0 situation. Then it is released from here, and as it is released, after some time, this chain links, these pieces of this chain will fall on the scale, and we will assume that there is no rebound. There is no rebound of pieces of chain on hitting the scale. So they just hit and stop. You can think of them as perfectly inelastic collision. Now by the time at t0 you have released, so after some time, let's say some part of the chain has reached here, and then it is like this. So it has fallen some distance y, let's say. Okay. So you are supposed to find reading of the scale. Matlab normal force you have to calculate. Okay students, so now you tell me students, as from here, as the chain falls, when it reaches here, what is the speed of these links which are going down? Of course, these pieces have already hit the scale, and according to question, they don't rebound. So they perfectly undergo inelastic collision, perfect inelastic. So they stop. But these guys are falling under gravity. Yes or no? So what is the velocity v when each piece has fallen? If this piece has fallen down by y, every piece has fallen down by y. So how much will be the velocity? Under root 2gy. This part you guys understood? Kinematics.
Yes, sir.
Yeah. Now let us choose system, and then we will draw forces, and then we will discuss the normal force. So I'm going to choose this as system. So my system is part of chain on the scale, which is at rest. Okay, so that is my system. Now tell me, this system is a variable mass system or constant mass system as time passes by? If you choose this as system, then mass is getting added, or you can't choose any random thing as system. No, you have to see something which will give you answer as system. So because I know this much part is on the scale, so I can easily find weight of that much part, because I know if if y distance has fallen, how much part is on the scale? How much length total is on the scale?
L minus y.
This is L. L minus y is the part which is here. How much is
Y
here?
part is there, no, sir.
Yeah, y part is there. So since I know y part is here, the length of this part is nothing but y only. If you open this part, it will be y. If you choose this as system, as you next moment when it comes, masses are getting added or not? Check. Masses are getting added, right? So when you draw for this system forces, what will you write? Here mg, that will be what? I'll write in terms of lambda, okay? So lambda into y part which is there here into g. So this is mg. This is normal. And 100% there will be thrust force, 100%, because masses are getting added. Now direction of thrust force, how to find, I told. For that, first you tell me relative velocity. So relative velocity is what? V dm minus V of system. These two are from ground frame, remember. V dm, every piece is falling with V velocity at this moment also. See here, this small part will get added here, no? This small part will get added. So that part is coming with what speed? Same as V. When you drop like this marker, all the parts are going with V speed at that moment. So this moment at time t, the speed of this part will be root of 2gy. System is at rest at that moment, the part which is already on the scale. So this is root of 2gy. Where it is? Down it is. Down. So since mass is getting added, thrust force will be same direction as relative velocity. So relative velocity is where? Down. So thrust force will be also down. Let us now calculate the magnitude of the thrust force. VR dm by dt. VR is root over 2gy. Actually, VR is root of tgy minus velocity of system, but system is at rest. dm, how to write dm? dm matlab mass of the small part. If I call this y, this small part, what will I call? dy. So dm is lambda into dy. And what is dy by dt? That is the speed with which y is changing, and y is changing with the same speed with which this end is moving. So that is v only. So this is root of 2gy lambda into root of 2gy, which is equals to 2gy lambda. So that is the thrust force. So once we have learned all the forces, Newton second law, net force equals to m into a of the system. Here system is at rest. So 0, what is the net force? N minus mg minus F thrust. So N should balance mg plus F thrust. M here matlab mass on the scale, which is lambda y into g plus thrust force is 2gy into lambda, which is equals to 3gy into lambda. Okay, students? And can you tell me, by the time the topmost end will reach the scale, last moment, when the last end will reach the scale, that time what will be your y? When this will reach here, L, because when this reached here, that time this is the reading. When this end reached here, this is the reading. So when this end will reach here, the total distance covered will be L. So that time the final reading for N will be 3g L into lambda, which is equals to 3g. L into lambda is mass of the whole wire, which is equals to 3 mg, which is very interesting. This is when it is about to hit, remember, okay, when the last end is about to hit, or just after hitting, I should say, not about to hit, just after hitting. Then after that, if you wait for some more time, then the reading will be what? Mg only. Once it settles down, then it will be mg. So why this extra force came, I hope you are understanding, because the links of the chain are hitting and it is getting stopped. It's hitting. So every time you hit the scale, the normal will suddenly increase. Okay. So here is your floor. There is a coil like this. Then you are lifting this coil till here. You have lifted, let's say, like this. So when you have lifted by y, if you want every part to move with same speed, what is the external force that you have to apply? That they may ask. Every point is moving with v speed. Then what happens? These particles which are at rest are getting added to these particles. So here, which is the best system to choose? This is the best portion of the wire to choose a system. Then what happens? As this is moving, these parts which are at rest has to suddenly move with v speed. So mass is getting added. So if you choose this as system, so if I choose this A and B as system, so here external force, and if y part you have pulled, then there will be mg of y part will be lambda into y, and then there will be thrust force. Now where will be thrust force? First, relative velocity, you tell, v dm minus v of the system. These dms are at rest in ground frame. system, this is being pulled by this force, but with constant speed. Okay. I'm tired. Bye. 2.5 hours we took. Good. Good. Navan, Nadesh, Shamant, Lakshmi. Who is there? Let me check.
Yes, sir.
Manjushree, Pallavi, Pritam. Oh, Pritam is also there, actually. So again, students, the last two parts are mainly for JEE people. That too, this part they may ask in advance only. But I think it's not so difficult. They can ask actually. Okay, chalo, bye. Thank you. I'll end the meeting. Huh? Anyone is writing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Chalo, bye.